All right, with day two, what we're going to be doing is more work with dilations and talk about calculating the scale factor and also what to do if your center of dilation is not zero. So we're going to review this again, and this is a reason why I want you guys to take notes, is so that you have definitions and rules in an easy to find place. So dilation is a transformation that stretches or shrinks a figure to create a similar figure. Now, in a dilation, a figure is enlarged, which is stretching it, enlarged, or reduced, that's shrinking it, with respect to a fixed point called the center of dilation. The scale factor of a dilation is a ratio of a side length of the image to the corresponding side length of the pre-image. Pre-image. So what that means in an equation or normal people words is that your scale factor is the image over the pre-image. Okay. You remember yesterday how you guys had those two pictures and we did the photo 2 divided by the photo 1 where we had photo 2 on top and then photo 1 was on the bottom, and then we divided that to get that scale factor. So a dilation where k is between 0 and 1 is a reduction, and a dilation where k is larger than 1 is an enlargement. So similar figures have, and we wrote this in our notes yesterday, corresponding sides are proportional and corresponding angles are congruent. Okay, so this is going to be good for us to refer back to from time to time again. All right, in example 1, the very first thing we're going to do is get rid of this misprint. It says draw a dilation of quadrilateral triangle ABC. Well, if there's 3 points, it is only a triangle, so it's not a quadrilateral. So that was the important first step. Now, we have our 3 points, and let's graph them. 2, 0, 6, -4, and C is 8, 2. So here's our original triangle, and we have a scale factor of 1/2. So that means we're going to multiply each value by 1/2. The x-coordinates by 1/2 and the y-coordinates by 1/2. And what we'll be doing is labeling those points L, M, and N. So A, we multiply each value by 1/2, we get 1, 0. In B, we multiply each value by 1/2, we get 3, -2. And for C, multiply each side by 1/2, we get 4, 1. So now we're going to plot those points. So we have L, M, and N. So that's how this reduced triangle looks like. Now, yesterday we said that the corresponding angles were congruent, and that the sides were proportional. And what we're going to look at now is to see if the corresponding sides are also parallel. So what we're going to do is we're going to find the slope of all 6 of these lines. Now, you could use a slope formula, and that's okay if you want to. However, I think it's probably easier to count our slopes since we've graphed this. So let's look at the slope of the brown triangle. So the slope of AB, so I'm going to count from A to B. So that was down 4 and right 4, which is -1. I'm going to find the slope of BC, and again I'm going to count from B to C. So it's up 6 and right 2, which is 3. And then I'm going to find the slope of AC. We went up 2 over 6, which is 1/3. So now I'm going to find the slope of the blue triangle of each side. Each side of the blue triangle. So the slope of LM, and if we count from L to M, we go down 2 and right 2, which gives us a slope of -1. And then let's find the slope of MN. We're going up 3 and right 1, which equals 3. We're going to find the slope of LN, which is up 1 and right 3. So you'll notice that the corresponding sides, let's not use that color, the corresponding sides have the same slope. And remember, if the sides have the same slope, that means they are parallel. So that gives us another property, that the corresponding sides are parallel. All right, let's look at the next page. And example 2 says triangle ABC will be enlarged with a scale factor of 12. What will be the length of A prime B prime? Now, this is not large enough, this grid over here, to graph with a scale factor of 12. So what we could do instead is find the distance from A to B. Now, you could use the distance formula, and it would work no problem. And some of you will want to do that, and I don't mind. I'm going to show you a little shortcut that might help some people. So if I go from point A and I go straight up, and I go from B and I go to the left, you guys will see that there's a right, you guys will see that there's a right triangle that is formed. And you'll notice that the hypotenuse of this blue right triangle was AB. So what you could do is say, well, 1, 2, 3, count the boxes from A to this point up here, and then count the boxes from B to that point. So 1, 2, 3, 4, 5, 6. And then you could use Pythagorean theorem to find out your hypotenuse, which would be the same as the distance. You might want to rewind the video a little bit and watch that again if that doesn't make sense. But this is a trick that will make finding the distances, I think, significantly easier. So that's what I'm going to do here. So AB is equal to the square root of 3 squared plus 6 squared. And that comes from the Pythagorean theorem after you simplify everything. So if you want, you can go ahead and still use the distance formula, or the Pythagorean theorem shortcut. So what I get with that is the square root of 9 plus 36, which is 45, and then the square root of 45. And we type that in the calculator, is 6.7. 6.71. We're going to use 2 decimal places. So then what we're going to do is we're going to multiply that value by 12 because that is our scale factor. So a prime b prime will be 6.71 times 12. And that gives me 80.52. And that would be our final answer. So let's look at example 3, where we're talking about shrinking a photo to fit on a magnet. So we have an original photo that's 8 inches by 10 inches. So I'm going to draw a picture. This is our pre-image. It's 8 inches by 10 inches. So when you get your school pictures, and you get your 8 by 10s, when they make the smaller ones, they do this type of calculations to make sure the photo still looks proper. All right, let's draw a model for our image. And 2.8 and 3.5. So the reason I put 2.8 on the bottom, right here, is because 8 is right here, and they're both the smaller numbers. 10 and 3.5 are the larger numbers, so I put them in the same spot between my pre-image and my image. So remember from the previous page that your K value is your image divided by pre-image. So you may be saying, well, which number do I use? Should I use this 10 or this 8? Well, it doesn't matter as long as you use the correct value of our image over here. So you could do 3.5 divided by 10, and that gives us 0.35. Or you could have also done 2.8 divided by 8, and that also gives us 0.35. So regardless of what we use, we get the same answer as long as you use the corresponding part. 2.8 corresponded with 8, and 3.5 corresponded with 10. So as long as you kept those straight, you'll be in good shape. All right, so example 4, you want to create a quadrilateral JKLM that is similar to quadrilateral PQRS. What are the coordinates of M? So what this means, we have JKLM is similar. This is a symbol for similar, PQRS. So M and S go together. So we want to find the coordinate of S. Now, we have the coordinate of S, so we want to find the coordinate of M. But first we have to find our scale factor, or our K value. So what I would do is I would look at point R and point L, because those are corresponding, and let's look at those points. Point L is 4, 0, and point R is 2, 0. So to calculate the the scale factor, we can divide the image by the pre-image. So 4 comes from the image, and r comes from the pre-image, so k would equal 4 divided by 2, which is 2. So that is our scale factor. Now we will multiply the coordinates of s by 2. The coordinates of s are 5, comma 5, which makes m 10, comma 10. Alright, now example number 5 looks a bit different. There's no coordinate plane here, so we're going to have to go based solely on the distances. So the distance from C to P prime is 14. That's what this distance is right here. And the distance from P to P prime is 4, which makes the distance from C to P 10, because 10 plus 4 is 14. So we know that x is 10. So what we'll do is use our formula, k equals the image over the pre-image, and the image, the distance from our center of dilation to the image, so the distance from C to P prime is 14, and the distance from C to P is just 10. And then when we simplify that, k is 7 over 5. All right, let's look at our last example. Now, here we have a dilation maps A, which is 3, comma 4, to 6, comma 4, so this is A, and this is A prime. I'll use a different color for that. And then B, 2, comma 2, to B prime, 4, comma 0. Okay, and now we're trying to first find the scale factor. Okay, well, we can do that. Scale factor, k equals the image over pre-image. Okay, so we can take any one of our values as long as it's the same. So we can take 6 over 3, and we get 2. And that would work for any of them. We could do 4 over 2, which is 4. The only one we could not use, 0, that wouldn't work. And 4 over 4 would not work as well. Alright, so now to find the center of dilation, what we're going to do, and it might help to have a ruler to do this in the future, is we need to connect B and B prime, but keep going. So I connect it and I keep going. And I'm going to do the same thing for A and A prime. Connect them and keep going. So my center of dilation is right here at 0, comma 4. Okay, so I know there was a lot to this, and it can be confusing, so if you need to rewind a bit, that's fine. So use this to help you with your homework, and don't feel like you can't reach out and ask questions. So good luck. I'll see you guys soon.